Dear students, today you are going to study about another ecosystem function, that is energy flow in an ecosystem. Already you have studied the two functions, that is productivity and decomposition. Energy flow in an ecosystem is always unidirectional. Energy flows within an ecosystem in an unidirectional manner. Only in one direction the energy flows, that is from the sun to producers, from producers to the herbivores, and from herbivores to carnivores. And energy again does not move in a reverse manner. Always, so from the sun we can find energy will be moving from solar energy to the, will be utilized by the green plants. Food will be prepared and the energy will be transferred from producers to herbivores and from herbivores to carnivores. So we tell that energy flow in ecosystem, it is unidirectional. All the types of ecosystem except in the deep seas we can't find the solar energy will be reaching. So all the ecosystem, they are being dependent on solar energy. Energy flow in an ecosystem follows two laws of thermodynamics. Energy flow in an ecosystem follows two laws of thermodynamics. The first law tells that energy can neither be created nor destroyed, but can be converted from one form into another form. So here the solar energy will be utilized by the producers and it will be converted into the organic compounds, energy rich organic compounds. So solar energy is converted into chemical energy of the food. So first law is applicable, that is energy is converted from one form to another form. The second law tells that every activity that utilizes the energy, there will be the loss of energy in the form of heat, or any activity that utilizes or there is a transfer of energy is accompanied by dissipation of energy. So as the energy moves from one trophic level to another trophic level, so there will be the loss of energy. So every activity that utilizes the transfer of energy is accompanied by the dissipation of energy. Dissipation of energy means loss of energy in the form of heat. See here, say some 1000 joules of energy, if it is present at the first trophic level, producer level, as the energy moves to the herbivores, the second trophic level, only 10% of energy will be transferred. It will be stored at higher trophic level, that is 1000 joules. From herbivore to carnivore, when it is been transferred, it is 10 joules. See here you can clearly notice that as the energy flows from one trophic level to another trophic level, only 10% of energy will be transferred. 90% of energy is being lost in the form of heat. 90 joules of energy is being lost. How? In the form of heat. It is being lost in the form of heat. So this was first studied by ecologist Lindemann and called it as 10% law. Who formulated 10% law? It is the Lindemann. Lindemann studied the energy flow in an ecosystem and he noticed that only 10% of energy will be stored at the higher trophic level. 10% law is defined as during the transfer of food and its energy, only 10% of energy is stored at a higher trophic level and remaining 90% of energy is lost in the form of heat. What is that? Energy is lost. Energy will be utilized by the organisms for their various activities. That is, or we can take respiration loss. During the transfer of food and energy, there will be transfer of 10% of energy and 90% of energy will be lost in the form of heat. So energy flow in an ecosystem is always unidirectional and follows two laws of thermodynamics. That is, energy is being converted from one form to another. Solar energy is converted into chemical energy of the food, and as the energy moves from lower trophic level to higher trophic level, only the 90% of only 10% of energy is transferred and 90% of energy is being lost in the form of heat. All the types of ecosystem, they are dependent on the solar energy for their functioning. Of the total incident solar radiations, the solar radiations which reaches the earth, they are considered as the incident solar radiations. In that 50% or less than 50% of incident solar radiation has a capacity to undergo photosynthesis. Such of the incident solar radiations are called as photosynthetically active radiation. Photosynthetically active radiation. In short, it is called as PAR. Photosynthetically active radiation. What is PAR? The incident radiations which has a capacity to undergo the photosynthesis, they are considered as PAR. How much percent of incident radiations, solar radiations are considered as PAR? It is 50%. Another 50% it will be scattered, it will be absorbed by the clouds, gases, so on. In that 50% of the PAR, so the total whatever the PAR in photosynthetically active radiation, only 2 to 10% is used in photosynthesis. Whatever the PAR we consider photosynthetically active radiations, in that green plants how much they use, what percent they use for photosynthesis? It is only 2 to 10% of PAR is utilized for the photosynthesis. Okay, so what is PAR? It is the solar radiations which can undergo the photosynthesis, which have a capacity to undergo photosynthesis. In that, it is only the 2 to 10% of PAR is being utilized for the purpose of photosynthesis. So now the three functions: productivity, rate of formation of organic matter or biomass in an ecosystem, what is decomposition, conversion of organic matter into inorganic substances by decomposers, and the third function, it is energy flow. Energy always moves from lower trophic level to higher trophic level in an one directional, unidirectional. One more function, that is nutrient cycles. Nutrient cycles later on you will study. So now the other concepts related to the ecosystem that you are going to study, that is food chain, food web in this class. You all know, in lower classes you have studied, yes? Yeah, you can remember some of the examples of the food chain. Before studying about the food chain, you have to know, that is trophic levels. What are trophic levels? Different steps in a food chain is called as trophic levels. Different steps in a food chain are called as trophic levels. Group of organisms, irrespective of size, having the similar food habit is also called as the trophic levels. Number of trophic levels is equal to the number of steps in a food chain. Number of trophic levels is equal to number of the steps in the food chain. So trophic level is being represented in the form of capital T. It is represented as capital T. If it is a first trophic level, we write it as T1, like that. T2, T3, so on. So in an ecosystem, A food chain comprises of maximum 4 to 5 trophic levels. The first trophic level is always occupied by the producers. Okay, if it is a grazing food chain. So what is a trophic level? The different steps in a food chain are called as trophic levels. Food chain is defined as sequential interlinking of organisms. Sequential interlinking of organisms involving transfer of food and energy with repeated eating and being eaten is called as food chain. Once again I will repeat. Food chain is defined as a sequential interlinking of organisms involving transfer of food and its energy. Food and energy with repeated eating and being eaten is called the food chain. So food chain where it will connect different types of organisms. What for? For the sake of food, or it might be it's a contained energy within the food. So where we can find where the lower trophic level organisms becomes the prey for the higher trophic level organisms. Like for example, simple example, vegetation, deer and tiger. So here different organisms are being connected, interact among themselves. What for? For food and energy. Where lower trophic level organisms becomes prey for the higher trophic level organisms. Deer feeds on vegetation. In turn, deer becomes the prey for the tiger. Eating and being eaten is being seen within the food chain. There are some certain characteristic features of food chain. Food chain, it is a nutritive interaction of biotic components within an ecosystem. All the biotic components, they are interacted. What for? For the food, or it might be the energy. Second characteristic feature important. Always food chain is straight. Always within an ecosystem, the food chain is straight, and the energy flow within an ecosystem is unidirectional. Energy flow within an ecosystem through the food chain, it is unidirectional. Usually, third characteristic feature, usually as the energy flows from one trophic level to another trophic level, 80 to 90% of energy is being lost. 80 to 90% of energy is being lost. Only 10% of energy will be transferred. Why? Because the producers, they require the energy for their own activities. Similarly, deer also, when they get the energy, deer also need some energy for their movements, for their metabolic activities. They utilize that energy, and that we call it as our respiration loss. In a food chain, there are 4 to 5 trophic level. Usually in a food chain there are 4 to 5 trophic levels. Maximum it is 4 to 5 trophic levels. Shorter the food chain, wastage of energy is less. If it is a longer food chain having maximum of 5 steps, 5 trophic levels, the wastage of energy will be higher. And another characteristic feature, the population size of the organisms present at lower trophic level is larger. As we move towards higher trophic level, the population size goes on decreasing. So population size goes on decreasing as we move from lower trophic level to higher trophic level. Another characteristic feature, there are some organisms which are present more than one trophic levels. Like for example, tadpoles and frog. Tadpole is herbivore, okay, and frog is the carnivore. So when it is carnivore, it is found at a 3rd or 4th trophic level. When it is on a tadpole, a larval form of a frog, it is present at the 2nd trophic level. Man is also an example for that. Man, when he is an herbivore, when man feeds on plant material, okay, so he is an herbivore, he can be present at 2nd trophic level. When he is a non-vegetarian, feeds on meat and like that, he can be at the next trophic level. Similarly, sparrow. Yes, it feeds on nuts, grains as well as feeds on insects. There are several organisms which are found more than one trophic level. So these are the several characteristic features of a food chain. Types of food chains. There are 3 different types of food chains. The 3 different types of food chains are grazing food chain, detritus food chain and parasitic food chain. The first type of a food chain, it is grazing food chain. In short, it is called as GFC. Grazing food chain, as the name itself tells, the grazing food chain is also called as predatory food chain. What are characteristic features of grazing food chain? Grazing food chain includes producers, consumers as well as decomposers. It always begins with producers. Energy flow starts from producers. First trophic level should be the plants. Second trophic level should be the herbivores. So hence grazing, as the name tells, grazing, the herbivores, cattle, rabbits, deer, they all feed on the plants, vegetation, herbs. So they graze on the plants, grazing. So energy flow is seen from producers. Okay, it starts from first trophic level is occupied by the producers and second trophic level it is by the herbivores and the other trophic levels it is by the carnivores. The grazing food chain depends upon solar energy. Because producers energy transfer begins from the producers. So producers they depend upon sun, solar energy for undergoing the photosynthesis. So energy is obtained, it is from the sun, solar energy. Why the grazing food chain is also called as predatory food chain? At every step we can find the action of predation, that is herbivores in ecological sense. Okay, so herbivores are also the predators. See here, so herbivores feeds on plants. In turn, herbivores are eaten by the carnivores. Carnivores feeds on herbivores. At each and every step, there is the act of predation seen. And among the three different types, the grazing food chain, it is a common type of food chain as well as the longer food chain. So, the grazing food chain includes all the three groups of biotic components, producers, consumers as well as decomposers. Energy flow begins from the producers, that is first trophic level is always occupied by the producers and next trophic level should be the herbivores. And this food chain is dependent on solar energy. In an aquatic ecosystem, more the energy transfer is through the grazing food chain. It was asked in one year in the final examination. In aquatic ecosystem, the major energy conduit it is through the GFC. Examples. These are few examples. The food chain might involve 2 steps, 3 steps, or it might be 4 or 5 steps. Vegetation, rabbit, fox, wolf, tiger, that is one. Grass, grasshopper, frog, snake, falcon, a common one you all know. Or two-step, vegetation and her elephant, vegetation, deer, tiger. Or if it is in an aquatic ecosystem, phytoplankton, zooplankton, small fishes, large fishes. So phytoplankton, zooplanktons, small fishes and large fishes. The second type, it is detritus food chain, DFC. The first trophic level in detritus food chain, it is occupied by, first trophic level in the food chain is occupied, it is occupied by the detritus feeding organisms. It might be decomposers or detrivores. And another characteristic feature of this detritus food chain, this food chain is dependent on the energy obtained from the detritus. So, grazing food chain gets the energy from the sun, and this food chain obtains the energy from the detritus. Energy transfers starts from detritus to the detritus feeding organisms, and detritus feeding organisms are in turn eaten by the other group of organisms. In the terrestrial ecosystem, the major conduit of energy is through the DFC. The major amount of energy transfer takes place through which type of food chain? It is the detritus food chain. Detritus, earthworm, sparrow and falcon. You can find it starts, energy flow begins from the detritus. First trophic level, it is occupied by the detritus feeding organisms. Another example, detritus, earthworm, frogs. Earthworms are eaten by the frogs. Frogs are in turn eaten by the snakes. Snakes are eaten by the hawk or falcon or peacock. So first trophic level in a detritus food chain, it is occupied by the detritus feeding organism. It might be decomposer or it might be the detrivores. The third type of the food chain, it is parasitic food chain. In this type of food chain, the food chain begins with the host and ends with the parasite. Important here, other two we have studied from where it begins, the food chain. But here in this food chain we are going to study where this food chain ends. The food chain should always end in a parasite. Okay? So food chain should end in a parasite. For example, tree which is a host, Cuscuta, yes, plant, man is a host, and intestinal roundworms. See, roundworms are the parasite. Another example, grass, sheep. Sheep is the host and liver fluke. So always we can see here in these few examples in this food chain, so it always ends in a parasite. So you can find in these several examples that food chain is always straight. Food chain is always straight, and through the food chain there is unidirectional flow of energy. And maximum how many steps you can find in a food chain? It is 4 to 5 trophic levels are being found within a food chain. The next is food web. The next concept which you are going to study, it is food web. Natural interconnections of several food chains. Natural interconnections of several food chains is called food web. When these several food chains which are being interconnected at various trophic levels, different trophic levels, it forms food web. Food web is seen both in terrestrial as well as aquatic ecosystem. What are the characteristic features of food web? Unlike the food chain, food web is never straight. Unlike food chain, food web is never straight. Food chain I was stressing there. So food chain is always straight, but whereas food web is not straight. Food web operates according to the taste as well as food preference. Food web operates according to the taste as well as food preference. See here, during drought condition, when the natural, in absence of natural prey, the predator will move on, switch on to the another type of the food. For example, in Sundarbans, the tigers, in absence of their natural prey, so they feeds on the fishes. Yes, they feed on the fishes or other smaller prey organisms. So, food web provides, third characteristic feature, food web provides alternate source of food. Food web provides alternate source of food, due to which another important feature of a food web is food web maintains the ecosystem stability. If the predator sticks on to only one particular prey species, so then what will happen? The predator, due to the starvation, its a population size will be decreased, or once it might become extinct. But food web will provide an alternate source of food in absence of its natural prey. So by which it brings about ecological stability. Ecosystem will be maintained stable by the help of food web, which provides an alternate source of food. So food web is never straight. It maintains stability, which operates according to the stage as well as food preference. Example, there are these several food chains. There are several food chains which are being occurring within an ecosystem. Like for example, if it is in a grassland or in a forest, okay. So there are several food chains here. 1, 2. This is third, fourth. This is fifth, sixth. This is 1/6 you can find. There are several food chains which are interconnected at several trophic levels to form the food web. See, first, vegetation, rabbit, jackal, wolf, tiger. This is one. Another, vegetation, deer or antelope, which is the deer which are being eaten by the tiger. Vegetation, rabbit forms, it is also found in this food chain. It is being connected to the next food chain. Vegetation, rabbit, fox, wolf, tiger. One more, vegetation, rabbit, fox and tiger. Similarly, vegetation, mouse, fox, wolf or fox, tiger, vegetation, mouse, wildcat and tiger. So here, so it provides and alternate. So rabbit is being eaten by both jackal as well as fox. Yes, fox is being eaten by the wolf as well as the tiger. So food web provides an alternate source of food. So by which it brings about ecological stability. It maintains the ecosystem stable. So in the next class, you are going to study about ecological pyramids, which is important for your examination theory as well as competitive examination. Thank you.